A new Big Bang, the birth of the universe through augmented Newtonian dynamics. The sequential discharge model, how energy became light, and light became matter. Introduction, restoring causality to cosmology. Modern cosmology presents the history of the universe as a sequence of mathematically consistent yet physically opaque events. Its equations describe how the universe evolves, but rarely why these transformations occur. This lack of causal transparency has produced a framework rich in descriptive power but poor in physical mechanism. The result is a universe that expands faster than light, whose size and age remain uncertain, and whose earliest moments depend on hypothetical entities that appear and vanish without identifiable cause. The problem is evident in the inflation hypothesis itself. Depending on the chosen parameters, inflation is said to have carried the universe from nothing to the size of a basketball, or to a fraction of its present extent. Such latitude reveals the absence of a defined physical driver. With no mechanism, the scale and duration of expansion can be adjusted freely to fit observation. Inflation thus functions less as explanation than as mathematical accommodation. In the first 10 to the power of -36 seconds to 10 to the power of -32 seconds, mainstream cosmology claims that the universe expanded by a factor of roughly 10 to the power of 26 to 10 to the power of 50, increasing its linear dimensions by more than 100 million trillion times. Some popular accounts even describe this as an expansion by a trillion. But such analogies are profoundly misleading. At superluminal speeds, the idea of spatial extent collapses. Distance cannot exist as something real, because no signal could bridge that separation. What inflation actually represents is not motion through space but the instantaneous geometric scaling of space itself, beyond the domain of cause and effect. The image of a basketball universe is thus misleading, confusing two different paradigms. During this phase, the universe is said to have expanded at superluminal speeds, faster than light itself. Yet at such speeds, distance has no meaning, no signal can cross the expanding geometry, and no two points can communicate. The familiar image of the infant universe, the size of a basketball, is therefore misleading, confusing scale with structure. Superluminal expansion describes not motion through space, but space itself losing measurable geometry. In the prevailing Big Bang model, inflation begins spontaneously, proceeds exponentially, and ends abruptly, leaving behind a hot plasma of radiation and particles. Its behavior is attributed to an unobserved scalar inflaton field, invoked solely to make the equations work. Energy is said to become matter, yet no identifiable process links radiation, pressure, or charge to stable mass. Causality, the foundation of classical physics, is replaced by a sequence of mathematical transitions, inflation, reheating, decoupling, each described by formulae but none by mechanism. Augmented Newtonian dynamics, and theory. AND theory seeks to restore causality to cosmology. It begins from the principle that every physical event arises from the behavior of real and virtual photons, the universal agents of energy exchange. In this framework, photons are not secondary carriers of light but the primary expression of energy itself. Their interactions, transformations, and alignments determine the structure of matter, the propagation of radiation, and the emergence of gravity. Where modern cosmology introduces abstract fields to explain expansion and structure, and theory replaces them with direct, mechanical processes grounded in energy conservation and charge interaction. By re-establishing a chain of cause and effect from the first instant onward, and theory transforms the Big Bang from a set of mathematical postulates into a physically intelligible event. It offers not a new universe, but a clearer understanding of the one that already exists. Structured energy and the expansion of the early universe. It is well known that the photon is a massless particle. What is less often appreciated is that, as a direct consequence of having no rest mass, the photon is pure energy, not matter in motion, but energy organized into a stable, self-sustaining form. In the Standard Model, photons are described as excitations of the electromagnetic field. However, this interpretation places the photon at a conceptual distance from its point of manifestation. It requires an independent, pre-existing field whose oscillations somehow generate individual photons. Given the immense photon densities observed in modern technology, from laser emissions to background radiation, this field-based explanation becomes increasingly inadequate. It cannot account for the efficiency, precision, or abundance with which photons are produced and sustained. According to augmented Newtonian dynamics and theory, photons are not remote field disturbances but are generated within electrons themselves. They represent energy organized into stable, coherent structures that can propagate through the universal photon medium. Each photon is a localized expression of structured energy, a unit whose stability arises from its internal symmetry and its continuous interaction with the surrounding virtual photon field. This understanding also redefines the nature of cosmic expansion. In the inflationary epoch of the Big Bang, the key question is, what exactly was expanding? According to the Standard Model, it was space itself, an interpretation that divorces expansion from the energy it contains. In contrast, and theory holds that it was energy that expanded. As the field of energy expanded, minute cooling occurred, allowing it to acquire internal structure. This process gave rise to vast, incalculable numbers of photons, innumerable structured energy units forming the first organized framework of the universe. If photons were indeed the first structured entities to emerge, then the expansion that followed was not an expansion into space, but the expansion of energy itself, acquiring order and coherence as it grew. The genesis of the photon and the birth of the electron. As the inflationary expansion progressed, it underwent minute cooling. This slight reduction in temperature allowed the energy field to acquire structure. Within this structured energy, stable electric dipoles formed, discrete units of energy identifiable as photons. They appeared throughout the expanding field in extremely large, innumerable numbers, representing the first organized configurations of energy in the universe. As the expansion continued, these photons lost energy, their energies decreased in proportion to the rate of expansion. Eventually, their energies dropped below the threshold of recognizable energy. They had transformed from being real photons to virtual photons, each with an individual energy of about 10 to the power of minus 51 joules. These virtual photons formed a pervasive, low-energy background field, what we know of today as dark matter. These virtual photons became the substrate of the universe, pervading every part of it, a medium capable of transmitting influence and supporting the later development of matter and radiation. The virtual photon field was largely static in position but retained full 360-degree freedom of orientation. This property allowed it to remain dynamically responsive while forming a relatively stable background through which real photons could later propagate. It was within this field that the next stage of structure began to emerge. As the energy field evolved further, fundamental particles began to take form from more complex configurations of structured energy. Among the first of these was the electron, a charged particle capable of interacting with the surrounding virtual photon field. The electron provided the first mechanism for energy regulation. By emitting and absorbing photons as required, it maintained internal equilibrium and mediated energy exchange with its environment. Through this process, the electron established the link between matter and light, converting a uniform energy field into an organized, self-regulating system. In this framework, photons represent the mobile phase of energy, while electrons represent the stabilized phase. Together they form the basic mechanism underlying all subsequent physical processes: radiation, matter formation, and gravitational interaction. The transition from pure energy to regulated structure thus marks the true beginning of the physical universe. The inflationary epoch. The earliest phase of this evolution, corresponding to what standard cosmology calls the inflationary epoch, is thought to have occurred between approximately 10 to the power of minus 36 seconds and 10 to the power of minus 32 seconds after the beginning. During this brief interval, the energy density of the universe fell dramatically as it underwent a geometric expansion by factors between 10 to the power of 26 and 10 to the power of 50. In the conventional Standard Model view, this expansion stretched spacetime faster than any signal could cross it, severing causal contact between regions. In the augmented Newtonian dynamics and framework, however, inflation is understood quite differently. In AND theory, the expansion was not the stretching of a pre-existing void but the unfolding of energy itself. Photons, as structured nodes of that energy, were integral to the process. They did not move apart through space, but were the form that space took as it expanded. Even though the geometric scale of the universe grew at superluminal rates, the underlying energy field remained a single, connected continuum. Spatial separation increased, but energetic cohesion persisted, because what expanded was not a set of particles but the continuous field that defined them. By the time the inflationary stage ended, within roughly 10 to the power of -32 seconds, the universe may already have reached a substantial fraction of its present size. What followed, during the period known as reheating, was not a second expansion but a reorganization of existing energy. The intense photon field, now cooled enough to permit localized stability, began forming structured loops and resonances, the precursors of electrons, quarks, and other particles. Matter did not appear in an empty universe, it condensed within a field already filled with light. In this view, reheating was the process by which the luminous continuum diversified into stable, particulate structures, while the residual energy of the field became the virtual photon medium that endures as the medium of space. Thus, the inflationary epoch defined the universe's extent, and reheating merely filled that preformed geometry with matter. From that point onward, the cosmos evolved not as an expanding void but as a continuous field of energy. Two main points arise from this narration. The first is that during the reheating stage events no longer unfolded at superluminal speeds but that they followed subluminal speeds, dictated possibly by the existence of a virtual photon medium, and the second is that historical events in the form of the Hubble constant indicate that events unfolded at a gradually slowing rate as the universe evolved. The sequential discharge model, from constrained inflation to cosmic maturity. In the augmented Newtonian dynamics and framework, the birth of the universe was not a single, unbroken explosion but a two-stage release of energy, a sequential process in which inflation and matter formation were distinct yet causally connected phases of one continuous event. This sequential discharge model replaces the abstract notion of a spontaneous scalar field decay with a physically coherent description of how energy decompresses from confinement, interacts with itself, and stabilizes as structure. Phase 1. The constrained expansion. The first release, corresponding to the inflationary epoch, was a phase of near-frictionless expansion. Energy, compressed to its highest possible density within the singularity, ruptured outward, delineating the scale of the universe within a fraction of a second. However, this expansion acted as a pressure-limiting barrier. The outward flow of energy was so rapid that it temporarily insulated the still compressed interior, the outward expansion creating an inward pressure. During this brief superluminal stage, the universe did not yet contain matter, only a field of structured energy, protophotons, streaming outward and cooling as they expanded. Phase 2. The secondary discharge. As inflation slowed, this insulation weakened. Residual energy confined within the singular region now found an open path of release into the already expanded domain. This secondary discharge marks the transition from a purely energetic to a material universe. The immense compression energy of the core, when released into the surrounding field, generated intense heat and gave rise to the first stable particles, electrons, quarks, and the earliest nuclei. This was not a separate explosion in space but a transformation of the same continuum, its innermost energies spilling outward to equilibrate with the field it had generated. The Hubble constant preserves a record of this transformation. In the early universe, when energy flowed freely, expansion rates were vastly higher. As the second discharge distributed mass throughout the field, inertia increased and the expansion slowed. The declining slope of the Hubble constant through cosmic time reflects this internal redistribution. Kinetic expansion energy gradually converted into the structural and gravitational energy of matter. The role of dark matter in accelerated structuring. The emergence of dark matter, conceived in and as the all-pervasive, residual photon field left behind by the inflationary expansion, further shaped this evolution. Although non-luminous, this vast background of virtual photons permeated every region of space, coupling weakly with real matter through alignment and tension. As the universe cooled and mass condensed, the dark matter medium acted as a stabilizing framework, guiding the aggregation of baryonic matter into galaxies and clusters. Because it provided a medium through which both light and gravitational alignment could propagate efficiently, it accelerated structural formation. Observationally, this is consistent with the Hubble shift curve, which shows that by about 4 billion years ago, the universe had already reached much of its present spatial extent and structural organization. The apparent acceleration observed in the recent expansion rate may thus be interpreted not as the action of an unknown dark energy, but as a consequence of dark matter's cumulative tensioning effect, the reorganization of the photon medium adjusting dynamically to preserve equilibrium as visible matter consolidated. 4. The universe nearing maturity. By the end of this second discharge, the universe had largely completed its transition from pure energy to structured form. Its temperature had dropped, but its geometry had stabilized. Expansion continued at subluminal rates, governed by the interplay between the inertia of matter and the elasticity of the photon field. The cosmic background radiation, interpreted in AND theory as dark matter, the residual luminescence of the photon continuum rather than a relic fireball, remains as the faint echo of that final stage of energy redistribution. Observational corroboration, the JWST evidence. Recent observations from the James Webb Space Telescope, JWST, lend remarkable weight to this interpretation. Galaxies detected at redshifts corresponding to less than 500 million years after the Big Bang appear far too large and chemically mature to have formed within the time constraints imposed by the Standard Model. In the prevailing cosmological framework, such complexity demands many hundreds of millions of years of stellar evolution and material recycling, a process that should not yet have begun at those epochs. Yet JWST's instruments reveal well-formed spiral and elliptical systems already in existence when the universe was scarcely 1/20th of its present age. Within the sequential discharge model, these findings are not anomalous but expected. Because the universe's second discharge released matter into a pre-existing continuum of dark matter, a photon-based universal fabric, the conditions for structure were present almost immediately. Matter condensed not in a void struggling to cool, but within a coherent, energy-filled medium that actively promoted aggregation and stabilization. Galaxies could therefore emerge far earlier than predicted by models that treat space as an inert vacuum and dark matter as a separate, unstructured component. What the JWST reveals, then, is not a crisis for cosmology but a confirmation of causality restored. Conclusion: a universe of continuity, not catastrophe. The sequential discharge model restores physical causality and coherence to the story of creation. Instead of a singular, inexplicable explosion, the universe unfolds as a sequence of ordered transitions, the release, redistribution, and reorganization of a single continuum of energy. The first discharge defined the universe's size, expanding the energy field to its natural geometric extent. The second defined its substance, transforming the remaining compression energy into heat and matter. From that moment onward, the cosmos evolved not as an expanding void, but as a continuous, self-sustaining field of structured energy. Where the Standard Model invokes spontaneous transitions, unobservable scalar fields, and arbitrary inflation rates to preserve mathematical consistency, the sequential discharge model requires no such inventions. Each phase follows from the last by clear physical necessity. Energy decompression gives rise to expansion. Expansion deceleration generates heat. Heat enables structure. Structure induces gravitational alignment and the slowing observed in the Hubble constant. In this framework, geometry, energy, and matter are consecutive expressions of a single unfolding process. The Hubble constant no longer marks a mysterious expansion rate but a thermal record, the measure of how rapidly the original heat of creation continues to diffuse through the cosmic field. Further, the apparent acceleration of cosmic expansion in recent epochs reflects not an external dark energy, but the dynamic adjustment of the photon-based dark matter medium, which regulates equilibrium as galaxies condense and align. Evidence from the James Webb Space Telescope reinforces this interpretation. The discovery of massive, mature galaxies at epochs once thought too early for such complexity challenges the Standard Model's linear chronology. Yet these findings fit seamlessly within the sequential discharge model, where matter formed rapidly within an already coherent and energy-rich medium. Dark matter, understood here as the residual photon field from inflation, provided the universal fabric through which light, gravity, and structure evolved together. It ensured that formation did not wait upon chance but followed naturally from order inherent in the field itself. Even the cosmic microwave background radiation, CMBR, long considered relic radiation from a primordial fireball, now finds a more natural explanation. Rather than being a remnant of a vanished epoch, it is present-day radiation arising from the vast, low-density regions of the universe, the quiet glow of the photon continuum itself. AND theory demonstrates unequivocally how such diffuse regions, sustained by the virtual photon medium, can radiate collectively to produce the observed microwave background. The CMBR, once the cornerstone of Big Bang orthodoxy, thus stands revealed as a red herring, evidence not of cosmic exhaustion, but of a living, radiant universe still in energetic equilibrium. In the end, the universe need not have emerged from chaos or nothingness. It began as energy-seeking equilibrium, a continuum transforming through stages of release, resistance, and renewal. The Big Bang, reinterpreted through augmented Newtonian dynamics, is not a cosmic accident but a self-consistent act of physical evolution. The first discharge defined its size, the second defined its substance, and together they define the harmony of an energy-filled cosmos still unfolding toward equilibrium.